And so hopefully, if you guys remember from the topics that I posted, the biggest thing is really understanding angle relationships. And so something that I'm going to actually put up here, hopefully that will help you out, is the difference between geometric relationships and um, measurement relationships, because this will be important for tomorrow's test. So first things first, with measurement, there's really only three things that I care about, and that's congruent, complementary, or comp, and then supplementary. So those three relationships are talking about the measures of the specific angles. So for example, if I were to say, oh, I see two angles, they're both 75 degrees. That means they're both congruent. Notice I didn't say anything about the angle relationship. I didn't say that they were alternate interior angles or vertical angles. I just know that those two angles are the same because they're congruent. I also know that two angles, when they add up to 180, they're supplementary. Again, notice I didn't talk about same side interior angles or straight angles. I just know that those two angles add up to 180. So the relationship that they have with each other with measurement is supplementary. With geometric, we bring in everything else. So we have our vertical angles. We have our straight angles. Straight angles are the two angles that add to make 180 to make a straight line. We have corresponding angles. They're in the same location as each other, but in different parts of the transversal. We have alternate interior angles, where they are inside or between the parallel lines, and they are on opposite sides of the transversal. And lastly, we have same side interior angles, which, similar to the alternate interior angles, they are between the parallel lines. However, this time they're on the same side of the transversal. Something to also keep in mind, I'm going to change the color here just so that we're clear. So with vertical angles, straight angles, with vertical angles, corresponding angles, and alternate interior angles, these are congruent, meaning they are the same angle measure. But for straight angles and alternate interior angles, these are supplementary, meaning they add to 180. So please, 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 again, study over the toolkit, look over your past classwork, take a look at your notes to see what kind of relationships your angles have. Because when I look at a picture like question 1 here, there's a lot going on. So we have to start to figure out, okay, what do we know about X? What do we know about Y? What do we see? And so something that I like to do before I solve these kinds of problems is I take a look at what are my markings. So for example, I know that this line is parallel to this line. I know that this line is parallel to this line. So we can try to figure out some stuff here. Now, this question is asking which statements are true. So with this kind of question on MyOpenMath, you're not going to really see this on the test. We just want to go through what are these statements true. So starting here, I'm looking at 3x plus y is equal to 180. So I'm looking at 3x, I look at y. These lines are parallel, right? And so what do we know about this specific angle, 3x and y? Well, notice this angle is inside of the parallel lines. And on top of that, they're on the same side of the transversal. This blue line here sort of acts as the transversal. It cuts through those two lines. And so because of that, they're same side interior. And we said earlier that same side interior angles are supplementary. So 3x plus y equals 180. This is true. They're supplementary. Now I'm looking at 2x minus 1 is equal to, 2x minus 1 plus 3x is equal to 180. So this one plus this one is equal to 180. And again, same idea here. These are between the two parallel lines. They're on the same side of the transversal. So yes, they are supplementary. They add to 180. 2x minus 1 is equal to 4 minus x. So comparing this angle right here and the angle right next to it. Well, keep in mind, whenever angles are right next to each other, they make a straight angle. So and they shouldn't be equal to each other. Instead, they should add to 180. So this one is not going to work. So in the last one, we have 2x minus 1 and 5y minus 10. Well, once again, lines are parallel, right? And so that's going to help us see that we have this angle and this angle here. Now, if they're parallel, this time they're on different sides of the transversal, this orange line that I'm drawing here. on different sides, and so that's going to be an alternate interior angle, and we say that they are congruent. So they have to be equal to each other, which in this case, it does work. So these three statements are correct. So again, please look over this. Look over this, the geometric versus measurement relationships. Geometric relationships are those names like corresponding, straight, vertical, alternate interior, same side interior. Measurement, I'm strictly talking about the measures of the angles. That's very different. Okay. So number 2, let's do another one here. We have angle 1 and angle 6. Again, make some markings here. This angle and this angle. So right away, we actually don't have a relationship that describes these two. However, I know that angle 1 and angle 4 are the same because they are vertical angles. So angle 1 is congruent to angle 4 because vertical angles are congruent. Vertical angles are congruent. So that means angle 4 also equals 4x plus 3. Now we also see here that angle 6 is 3x plus 34. Now if we take a look at this angle 4 and angle 6 here, what kind of angles are those? Well, again, they're between the parallel lines here. We also see that they're on the same side of the interior of the transversal. So they are same side interior angles. So angle 4 and angle 6 are same side interior angles. So because of that, they're not congruent to each other. They add to 180. So to set it up, you just have to add both angles together. 4x plus 3 plus 3x plus 34. And set it equal to 180, and we solve for x. So I see like terms. 4x and 3x make 7x. 3 plus 34 equals 37, equals 180. And so we just keep going from there and solve for x. Cancel, so 7x equals 143, I believe. It will get you a decimal, and it says round your answer to the nearest thousandth. So x equals, I'll pull my calculator here. So 143 divided by 7. Now it says to round to the nearest thousandth, right? And so 20.428 is the thousandth mark. So the number after the 8 is a 5. That means we have to round up. So instead, it's going to be 20.429 instead of 8, because the 5 is after the 8, and that means we have to round up. So 20.429 is our answer here. Okay. Skipping number 3, number 4. Number 5 is a great question because we're trying to find the area of the shaded region, right? There's actually a lot of ways that you can do this. So there really is no right way to do it because of that. The way that I'm going to show this is I'm actually going to do a little trick here where I'm going to do the area of the whole rectangle, and then I'm going to find each area of the triangle and subtract it from the area of the whole rectangle. I don't like this triangle in particular, the shaded region, because it's not flat. So it's really hard to gauge what the actual height of the triangle is. So that's why it's a little hard to find. So that's why it's better to just figure out the area of the whole rectangle and then subtract those little areas. So to start, my whole base on the top is 14 plus 12, which is 26. The height on the left side of the rectangle is 9 plus 6, which is 15. So area of rectangle equals 26 times 15. This is a very big number. I need a calculator for it. That's 390. So 390 is the area of the whole rectangle. Now, I'm going to split up my triangles into numbered triangles, I guess. I'll call this 1, triangle 2, triangle 3. Now, the base on the bottom matches up with the top because it's a rectangle, so that means this is 26. And the height also matches on the left side, so the height is 15 for that triangle. So I have area of triangle 1. Cool. Excuse me, I have my base is 14 here. My base is 14 and my height is 9. So 1/2 times 14 times 9. I'm going to set all my equations up and then figure out the areas. Area of triangle 2, that's the right one, is 1/2 times 12 times 15. And then area of triangle 3, is 1/2 times base, which is 26, times the height, which is 6. So I have a bunch of areas to find. So for the first one, I have 1/2 times 14 times 9. So I'll do 14 times 9 and then divided by 2. So I get 63. Second one, I have 12 times 15 divided by 2. That's 90. Last but not least, I have 26 times 6 divided by 2. I get 78. So I have all three areas of my triangles. So to find the shaded region, I need to subtract the whole 390 minus each of my individual unshaded triangles. Minus 63, minus 90, minus 78. So we take a look at this. We have 390 minus 63 minus 90 minus 78 equals 159 as my area. And so that ends up being a regular integer, meaning a whole number. And that's going to be working there. And so equals 159 units squared. So something to keep in mind, because I reminded you from the previous test, you need to make sure you label your units. It is very important that you do so. Okay. So we know how to find the area of a triangle, area of a parallelogram. Remember, if I give you a shape like this, it's asking to find the perimeter and the area, right? Do not forget to label your blank sides, because that will probably help you for your perimeter. And when I mean probably, I mean it will help you for your perimeter. For area of a parallelogram, it's base times height. So that hasn't changed. It's similar to a rectangle. But the question is, which one's the base? Because it looks like the red height 50 here is the height, which is true. It's a vertical line that goes straight up and down. Generally, in some questions, you'll see that right angle. But which one's the base? Well, 55 is going to be the base. 52 is not the base or the height. It's actually the slanted height here. So we don't want to use that. So when we're calculating it, I'm not going to calculate this out. It's going to be 50 times 55, base times height. Okay. So again, make sure you find perimeter and label your units correctly. If it's just perimeter, it's just inches or no inches squared. Area, however, you need to make sure you have your final answer as inches squared. And so I'll put that in the little answer part, square inches or inches squared. Okay. Trapezoid area, very important. Remember that it is base 1 plus base 2 times the height divided by 2, or another way of writing it is 1/2 times base 1 plus base 2 times the height. So when we talk about base 1 and base 2, that's the top and the bottom flat sides. So generally base 1 is the top, base 2 is the bottom. It doesn't matter how you write it, because it will be in the same, it will add to the same number. Then make sure you know that the height is a vertical line. It's not the slanted height. So this is not the height. This is not the height. This 14 right here is the height. Okay. So to add it up, I'm not going to solve it. 7 plus 17.5 times the height, which is 14, divided by 2. So plug that onto your calculator. I would take things step by step. So what I would do if I were to solve this is add the numbers together. So I have 24.5 times 14. Do that in your calculator next, and then divide it by 2. Take it one step at a time instead of trying to put everything in one line. That way, you don't get an error with your order of operations. Because obviously, your calculator will just read whatever you put down. But if your order of operations is wrong, that might screw up the problem. So take things slowly, take it step by step. Okay. These triangles are helpful. So if you haven't had a chance to go through this question, again, I would just Google these words if you don't know what they are. If we're talking about equiangular, if we split it up, there's equa or equal and then angular, right? So equal angles. So if we're talking about definition, all the angles have to be congruent. For that scaling, all the sides are different. Acute angle or acute triangle, meaning that there's one angle that's less than 90 degrees. Generally, that means all the angles are less than 90. And that's it. I can keep going on and on, but you guys get the idea. Now, this is a very important thing. This is why I wanted to make this video in particular, because we haven't really studied probability, but I'm pretty sure if I were to ask you just a basic question like this, it's pretty straightforward. So it says the ball is drawn randomly from a jar that contains 9 red balls, 3 white balls, and 2 yellow balls. We have to find the probability of the given event. First thing you have to do in any probability question is to figure out how many total balls do I have in this jar. This is very important, okay? And so I think I am limited to what I can do right now with our paint here. So I think what I'll try to do is I'll try to explain it just in words here because I can't really draw anymore for some reason. It's okay. So if I have 9 red balls, 3 white balls, and 2 yellow balls, I add them all together. So 9 plus 3, and then plus 2. So 9 plus 3 is 12, and 12 plus 2 is 14. So I have 14 total balls here. But then I need to find the probability that a red ball is drawn. Well, how many red balls do I have? I have 9, right? So my probability, I can write it as a fraction, is 9 over 14. There's 9 total red balls over the total amount of balls in the jar. Okay. For the white ball, I have 3 white balls, but I still have the same amount of total balls. And so I would do 3 over 14 there. And then lastly, I have yellow balls. I have 2 out of 14. But if it's possible, please reduce your fraction. 2 goes into 14 7 times. So really, when you reduce it, it's 1 over 7. So make sure you show the work there. If you just write 1 over 7, great. You might get it right. But I prefer you show your work, because if you don't get it right, you make an error. I don't know where you're getting that from. And I don't want to make any assumptions. Okay. All right. And then, yeah. So hopefully this helps. If you have any questions, again, please email me. I'll try to get back to you as soon as possible. But yeah, let me know if you need anything. Have a great day, and we'll see you later. Bye-bye.